The first thing we did was find the displacement in the x direction. We measured from the person that shot it to the cup, and it gave us a displacement of 2.7 meters. Next thing we did was we found the displacement from the cup to the floor with a displacement of 0.68 meters. And then we proceeded to subtract that from the displacement of the person that shot it to the floor, which was 1.65 meters, which gave us a total displacement of negative 0.97 meters.
We are going to derive an equation so we can find the initial velocity of the ping pong ball when it leaves my hand to get into the cup. So we have our picture, and we know our displacement in the y is negative 0.97 meters. Our acceleration in the y is negative 9.8 meters per second squared. Our velocity final in the y, we don't know. We are looking for our initial velocity in the y. And our time, we're going to be able to calculate using a stopwatch. So we use our motion equations. So we have our displacement in the y. We're looking for our initial velocity. We're going to be able to find our time once we use our stopwatch. So then we have negative 9.8 times 1/2 to get negative 4.9 meters per second squared multiplied by our time squared. So we have our displacement plus then 4.9 meters per second squared times our time squared, which we just brought over to this side. And we're going to have our time, which is in seconds, so we're going to have second squared over a second squared, so that'll cancel. So we're going to have a meter plus a meter over a second, which gives us our unit of velocity.
Alright. This is our equation for how far the ball went when we threw it. And what we did is we divided by time to get v naught of x, and now with this right here, we're going to plug it in this equation right here. Alright, to find the initial velocity of the ball that we threw in the cup, we have to calculate the components of the ball using the initial velocity in the x and the initial velocity in the y. The displacement in the x is 2.7 meters. The displacement in the y is negative 0.97 meters, since up and right is positive. The acceleration in the y is negative 9.8 meters per second squared, because only gravity is acting on the ball as the ball travels towards the ground, or towards the cup in this case. We don't know velocity initial in the y, and we don't care about velocity final in the y just yet. The time it took for the ball to travel from the hand to the cup was 0.73 seconds. Okay, so using the Pythagorean theorem, we got the equation that velocity initial is going to equal the square root of velocity in the x squared and velocity in the y squared, because a squared plus b squared equals c squared, as shown up here. To get the velocity initial in the x, we use the simple equation displacement over time, since the acceleration for the x direction is going to be the same throughout the travel, and it's going to be 0 meters per second squared. So the velocity in the initial in the x and the final in the x is 3.7 meters per second squared. To find the velocity initial in the y, we use the motion equation that neglected velocity final in the y and came out to be 2.25 meters per second. And we plug both of these into the equation, the derived equation, and the velocity initial is 4.33 meters per second.
Alright, to find the angle at which we threw the ball, we use tangent theta equals the velocity initial in the y, which is this one, over the velocity in the x, which is here. These two numbers we found with what Christian did a moment ago. So now, what we plugged in was just the velocity initial of the y here, which is 2.25 meters per second, over 3.7 meters per second, which is right here. Then we use a tangent inverse to get rid of the tangent here, which left us with theta here. And finally, we just calculated that, which gave us 31.3 degrees.